Which gas is present in chips and wrapper packets? Welcome to Sri Krishna Education channel. In this video, I am going to explain about the redox reactions and the corrosion and density process of class 10 science. So let me discuss the redox reactions. Redox reactions, it is includes reduction plus oxidation. It includes the two kind of reactions, reduction reactions as well as the oxidation reactions. Okay, first oxidation reactions. It is a chemical process in which the substance gains oxygen or loses hydrogen. This process is known as oxidation. For example, magnesium, which is reacting with the oxygen gas to form magnesium oxide. Previously, we have a question that why the magnesium ribbon cleaned before burning. Here, the magnesium ribbon, it should be cleaned before burning because magnesium is a metal which can react with the atmospheric oxygen and form magnesium oxide. So to remove the magnesium oxide layer present on the magnesium ribbon, we need to clean the magnesium ribbon. So this is the question which you got previous video. Next, another example, when H2S, which is reacting with the chlorine gas, it form hydrogen chloride plus sulfur. Another example, the copper metal, which is reacting with the oxygen gas, okay, while heating it forms cupric oxide is formed. So all these cases, either addition of oxygen or loss of hydrogen which is taking place. So these are comes under the oxidation reactions. Next, reduction. It is a chemical process in which a substance gains hydrogen or loses oxygen. It would be comes under the reduction. Okay, for example, when the zinc oxide, which is treating with the carbon, it forms zinc plus carbon monoxide. Similarly, when Fe2O3, ferric oxide, which is treating with the carbon monoxide, it forms iron plus carbon dioxide. Another example, when the N2 gas, which is treating with the 3 moles of hydrogen gas, it forms the 2 moles of ammonia. So in the first case, with respect to zinc, here the loss of hydrogen which is takes place. In the reactant side, the zinc is having the oxygen, but the product side doesn't have any number of oxygen. Means loss of oxygen, which is a reduction. And with respect to iron, the iron in the reactant side which has a 3 number of oxygens, but in the product side doesn't have any number of oxygens. Means removing of loss of oxygen. So it would becomes under the reduction. Whereas the third case, when the N2 gas which is reacting with the hydrogen gas, it forms ammonia. Here the nitrogen in the reactant side does not have any number of hydrogens, but the product side it has 3 hydrogens. Means the gain of hydrogen. Gain of hydrogen also comes under the reduction. So this way the oxidation and reduction can be identified. Next, the redox reactions. Okay, redox reactions which are nothing but the reactions in which both oxidation reaction and reduction reaction takes place simultaneously. So those reactions are called redox reactions. Okay, in this case, both the oxidation reaction and reduction reactions which are take place simultaneously within the reaction, that would becomes under the redox reactions. Here, example, CuO, cupric oxide, which is treating with the hydrogen gas, it form copper plus water molecule. Here with respect to the copper, here the copper has oxygen in the case of the reactant side, whereas the product side it does not have any number of oxygens. Means there is a loss of oxygen. Loss of oxygen which is nothing but it is a reduction. Whereas hydrogen, H2 gas, which is reacting with this oxygen and form H2O. So in this case, the gain of oxygen which is takes place. So gain of oxygen which is a oxidation. Here in case of the with respect to copper, it is a loss of oxygen, it is a reduction. Both are takes place within the same reaction. So it would becomes under a redox reaction. The similar way, another one, MnO2, which is reacting with the hydrochloric acid, it form MnCl2 plus Cl2 plus H2O. In this case, the reactant side Mn which has the two number of oxygens, but whereas the product side Mn does not have any number of oxygens, means it undergoes reduction. Whereas hydrogen the reactant side it doesn't have any number of oxygens, but the product side it has the one oxygen with it. So that means it is undergoes oxidation. Here the Mn undergoes reduction and the hydrogen undergoes oxidation. Other example, H2S which is treating with the Cl2 gas to form HCl plus sulfur. So in this case the sulfur consisting the hydrogens in the case of the reactant side, but the product side does not have any number of hydrogens, means it is the loss of hydrogens. So loss of hydrogens which is comes under the oxidation, whereas chlorine which is gain of hydrogen means it is comes under the reduction. So this way the redox reactions can be identified. In that case both oxidation as well as the reduction which can be takes place simultaneously. Next, oxidizing agent means the substance which can bring about the oxidation of the other substances, which is called an oxidizing agent. Here the examples like CuO. CuO undergoes reduction, but it is causes for the oxidation of the H2, so it is comes under the oxidizing agent. CuO is a oxidizing agent. Okay, next another example, H2S. Okay, in the H2S plus Cl2 it forms HCl plus sulfur. So in this case Cl2 undergoes the reduction. Okay, this is due to the H2S. So here the Cl2 which undergoes the reduction, so it is a oxidizing agent, which the substance which undergoes the reduction, that would be the oxidizing agent. The next reducing agent, it is a substance which can bring about the reduction of other substances which are added to food containing fat and oils. So this would be comes under the reducing agent, the substance which can bring about the reduction of the other substances, that is simply known as the reducing agent. So here the reducing agent in case of this H2 undergoes oxidation in the above reaction, so that is a reducing agent. Similarly H2S it undergoes oxidation, so it is a reducing reagent. So this is the oxidizing agent, reducing agent and the redox reactions. Next, corrosion. It is the slow eating up of the metals by the action of air and moisture on their substances. Okay, this process is known as corrosion. Slow eating up of the metals by the action of air and the moisture on their substances. So that is this process is known as the corrosion. So the rusting of iron or corrosion of iron. Okay, rust which is nothing but the hydrated ferric oxide. Okay, Fe2O3xH2O. So this is the chemical formula of rust. So this can be takes place when the iron or any metallic objects which are placed in the atmosphere. So that case these metallic objects which can be react with the atmospheric oxygen or moisture and forms the corresponding oxides. This process is known as rusting or corrosion process. So here the conditions necessary for the rusting, that is air or oxygen. Second one is the moisture. So any of these which are required for the rusting of any of the metallic substance. Next, how can we prevent the corrosion? How can we prevent the rusting? Here the rusting can be prevented by the painting or by the oiling or greasing or by the galvanizing. So by this process we can easily prevent the corrosion process. So in case of the paint, so metallic objects when we painted, so that case atmospheric oxygen cannot be contacted with the particular metal, so directly cannot be contacted, so that the rusting process can be prevented certain extent. Next, by the oils and greases. When we apply the oils and greases on the surface of the metals, so that case also the atmospheric oxygen cannot able to contact directly with the metal, so that case also the rusting can be prevented. Next, by the galvanizing. So on the surface of a metal, more rusting metal, the less corrosive metal we place. So that case also the corrosion process can be prevented. This is in the case of the slow eating of the metals by the atmospheric oxygen or moisture. So that case the strength of the metals and the lustrousness of the metal can be destroyed. Next, rancidity. So it is a oxidation process of fats and oils due to which they become rancid, their smell and taste that will become changes. The rancidity is a process that food items which can be undergoes oxidation and it will become spoil. So this process is known as the rancidity. It is also oxidation, but that is in the case of the food items, whereas corrosion also it is a oxidation process, but that can be takes place in the case of the metals. Now the rancidity which can be prevented by taking the antioxidants, by adding the antioxidants in the case of the food items. So that case the rancidity can be prevented. And the rancidity also can be prevented in case of the pickles, okay, which can be added the X amount of salt. That case the rancidity can be prevented. And the in case it can also add the X amount of oil than rather than the level of the pickle. So that case also the rancidity process can be prevented. So in the case of the chips and wrappers, these packs which are packed in the presence of the excess of nitrogen gas. So when the nitrogen gas is filled in the chips and wrapper packets, so that the oxidation process of these chips packets and the wrappers cannot be directly react with the atmospheric oxygen, so the rancidity process can be prevented. So this way the rancidity and corrosion can be prevented by applying the suitable methods. Okay, thank you.